Let us look at question number 46 now. Following orders are given. So the first statement talks about the acidic strength of the hydrides of group 16. So as we move down the group, the acidic strength increases. So the given order is correctly given to us. If we talk about the second option now, so this option talks about the basic strength of the hydrides of group 15. And if we move down the group, we know that the basicity decreases. So this order is also correct. If you look at the third statement, we have HClO4, HBrO4, HiO4, and we have to compare their acidic strengths. So students, this order is also correct. We can attribute this fact to the decreasing electronegativity of the central atom, which is the halogen. So all of these three orders are given to us correctly. And for this question, we have to select the first option as the correct answer. Let us look at the next question now. Question number 47. The standard electrode potential for Hg2 to Hg and Hg2 to Hg are 0.799 volt and 0.855 volt respectively. Equilibrium constant of the given reaction at 298 Kelvin is. So we have been given this reaction and we have to comment on the K value for this reaction. So let us first try and interpret the data which is given to us. So E0 Hg2 plus to Hg. So we can write it in the reaction form. So we're going to have Hg2 plus 2 electrons converting into 2Hg. So the E0 value is equal to 0.799. And if we talk about the other data, which is the E0 of Hg2 plus to Hg, we have Hg2 plus 2 electrons again giving us 2Hg. So the E0 value is equal to 0.855 volts. So we have to generate this required expression using these two reactions. So if we call this as reaction 2 and if we call the above reaction as reaction 1, we can see that if we subtract the first reaction from the second reaction, we're going to generate this reaction. So we can do the same thing with the delta G's as well. So the delta G for the net reaction or the delta G naught for the net reaction can be written as delta G naught 2 minus delta G naught 1. So the delta G naught net can be found out using this expression. So we can now substitute the values. The delta G naught net will give us minus RT ln K. And if we talk about the delta G naught 2 minus delta G naught 1, we're going to have minus 2F into E2 minus E1. So this is 0.855 minus 0.799. So we're going to have minus RT ln K minus 2 into F into 0.056. So we can simplify this expression to give us 0.059 log K by 2 equal to 0.056. So this on simplification will give us a log K value approximately equal to 1.89. So we can clearly see that the value of K has to lie between 10 and 100. And if you look at the options which are given to us, we can clearly see that the only value which lies in the given range, which is from 10 to 100, is the fourth option. And students, for this question, we have to select the fourth option as the correct answer. Let us look at the next question now. Question number 48. Two radioactive nuclides X and Y have their half-lives of 30 and 10 minutes respectively. A sample contains the number of nuclides of Y to be 4 times that of X. How much time should elapse so that the number of nuclides of X and Y become equal? So let's start with Y now. Since it has a lesser half-life, so it is going to have more number of half-lives. So we can probably talk about Y. We can assume that the number be 4n initially. So 4n will convert into 2n in 10 minutes. The 2n will convert into n in another 10 minutes. And the n will convert into n by 2 in another 10 minutes. So the radioactive decay follows first order kinetics and the half-life is constant irrespective of the amount of the substance undergoing radioactivity present. So in a matter of 30 minutes, we can see that the concentration of Y has decreased from 4n to n by 2. And if we talk about X, it has only n number of nuclides as given to us in the question, and in 30 minutes it is going to be equal to n by 2. So we can clearly see that after 30 minutes both these species are going to have the same number of nuclides in the mixture. So students, for this question we have to select the correct option as option 2. Let us look at the next question now. Question number 49. So question number 49, it says, in the process of extraction of gold by the following reaction. So we have X getting reduced by zinc, giving us Y and Au. So this is the reduction of the complex which was formed after leaching. So we can have AuCN whole twice negative plus Zn, giving us Au plus ZnCN 4 2 negative. So students, for this question we can clearly see that we have to select the fourth option as the correct answer. So this is the compound X and this is the compound Y which is formed. Let us look at the next question now. Question number 50. In the Freundlich absorption isotherm given by X by M equal to K into P to the power 1 by N, where N is greater than 1, the following statements are given. So S1 says that the limiting condition when 1 by N equal to 0 implies that X by M equal to constant, that is the adsorption is independent of pressure. And S2 says that the limiting condition when 1 by N equal to 1 implies that X by M equal to Kp, which implies that X by M is directly proportional to P. That is, the adsorption varies directly with the pressure. So the examiner seems to be interested in which of the above statements are supported by experimental results. So both of these statements are validated by the experimental observations for different experiments carried out. So both S1 and S2 are correct, and students, for this question we have to select the third option as the correct answer. Let us look at the next question now.